Let's talk about the central limit theorem. It concerns the sampling distributions of the sample means that could be obtained from various random samples of a population. Think of it this way. Each time you select a sample from a population, you will obtain a slightly different mean and variance. What the central limit theorem says, though, is that the sample size increases, the sample means that could be obtained from these various samples tend to be normally distributed around the population mean, and its variance shrinks in size as n increases. Thus, the mean of the sample means should be approximately equal to the mean of the population, and the variance approximately equal to the population variance divided by the sample size. Why do we divide by the sample size? Because the normality assumption, the central limit theorem, is based on sample size. At its simplest, the central limit theorem says the bigger the sample, the more likely the distribution is to be normal. Even cooler, this tendency towards normality of the distribution of the sample means happens regardless of the initial shape of the distribution if the sample is large enough. So the question you need to be asking is, how large is large enough? Generally speaking, a sample of size of 30 or more is considered to be large enough for the central limit theorem to take effect. The closer the population distribution is to the normal distribution, however, the smaller that sample size is needed to demonstrate this theorem. Populations that are heavily skewed or have several modes may require larger sample sizes. Why does this matter? Well, it's impractical to collect all of the data from an entire population, so we rely on samples to draw conclusions about the population. The central limit theorem gives us confidence in the statistics we obtain from our samples as being good estimates of our population parameters.